Now this problem is going to be a vertical circular motion problem. So we have our circle, and it's going to be swung in a vertical way so that at the top things are going to be different than at the bottom. So we know that the mass of the object is going to be 0.15 kilograms. And we're also told that the radius, or the length of the string, is going to be 1.1 meters long. So it's swung in a vertical circle. So we want to figure out the speed that it has to have at the top in order to clear that, which we're going to call the critical speed. So in order for it to make a circle, it's got to move this fast. And then we want to figure out the tension, both at the top and the bottom. So what we want to do first is figure out what we know and what we can get from here. So we know the mass, we know the radius. We don't really know anything else. But what we do know is that at the very top, the object is just going to get by because of inertia. So that means that at the tip top, the centripetal force is only going to be equal to gravity for part A, which means we're going to have mv squared over r. Now this doesn't work all the time. This is only happening because the problem is just specifying that it barely clears it. So we have mv squared over r equal to mass times gravity. And then because of this, both the masses are able to cancel out. So we're left with v squared over r equal to g. And we're going to be looking for the velocity. So that is going to end up being the square root of r times g, which in this problem the radius is going to be the 1.1. So it's going to be the square root of 1.1 multiplied by 10, because we use 10 for gravity. So when we do that, we're going to end up with 3.32 meters per second. So that is the minimum speed that it could have in order to get all the way around at the top. So the critical speed is that size. Now the next part, what we want to do is figure out exactly how fast is it going to be when we hit the bottom. Now because of what's going on, the speed at the bottom is basically going to be double the speed at the top based on this, because the way that the forces are now additive. So what we have at the bottom, we're going to have a force of tension minus force gravity, and that's going to be equal to centripetal. And if we're looking for tension at the bottom, that's going to remain Ft. Force of gravity becomes mg, and centripetal force is mv squared over r. So we know all the masses, we know the radius, and we know everything else that we have to in order to solve the problem. So force of tension is going to be mv squared over r plus mass times gravity. So that's going to be 0.15 multiplied by speed, which we said was going to be double this one. And normally for a problem you're not going to have to be doing anything that extensive and have to know that. You'll be given that. And then the radius is 1.1, and that's going to be plus 0.15 multiplied by 10. So we're going to get a force of tension, which is going to be divided by 1.1. 7.49 newtons. So at the bottom, it's going to be 7.49 newtons. Now at the top, what happens is in our free body diagram, the force of tension and the force of gravity are now pointing in the same direction. So instead of being subtracted like they were of the other equation, they're going to be additive. So tension plus gravity is going to equal centripetal. So then what we have is force of tension equal to centripetal minus force of gravity. And the centripetal force is going to be the same value. It's going to be 0.15 multiplied by v squared over r, except now at the top, if we're talking about what's going on here, we're going to end up using the 3.2. But realistically, because we have calculated at the top the 3.2, that's only when it's just passing by because of gravity, and that's not what we're worried about. We want to go through a situation that's real life, so we're going to keep it 6.63. So we do 1.15, 6.63 squared, divided by 1.1. So our centripetal force is 5.99 and our force of gravity is 1.5. So our force of tension at the top is going to be 4.49 newtons. So it's a pretty big difference in between, but this is a 150 gram object, so it's pretty sizable. So when you have your forces for your vertical circles, what they're going to look like, and you have your string, and there's your center. Okay, so radius, radius. Okay, so at the top, your object is going to have a force of gravity, which is pointing straight down, and it's going to have at the bottom a force of gravity, which is pointing straight down, of the same size. Then at the top, it's going to have a centripetal force, which is pointing inward, and that's going to be made up of the force of tension and the force of gravity. And at the bottom, the centripetal force is again made up of force of tension and force of gravity. So bottom of the circle, you have one up and one down. Top of the circle, you have them both pointing downward, which results in the addition and the subtraction of the previous problem formulas. So for a vertical circle, that's all you're going to need. How to find the centripetal force using tension, and how to find speed if it just barely clears.